The first is the butterfly effect. I don't know if you've heard of the butterfly effect, but it's a part of chaos theory that says that there are cases where the beating of a butterfly's wings in Mexico can change the weather in, and then pick your favorite place, London, Moscow, whatever it is. And the idea there is that sometimes systems are very, very, very complex, and very small changes in the system can have dramatic effects. And there's a whole story behind how this came about. I encourage you to look up butterfly theory in Wikipedia.
Welcome to Geothermal Unleashed, where we will explore the cutting edge of geothermal energy. I'm Elizabeth Cambre from the Vallourec New Energies team, and I'm here to help educate and document geothermal's rise in the global energy transition. Today, we're going to have a conversation with Malcolm Ross, who is the Director of Strategic Marketing at Eavor Technologies. Malcolm is a geothermal enthusiast. He is Houston-based with one foot in academia and the other in geothermal. He blends hard science, policy savvy, and economic precision into a single unstoppable force for decarbonization. Whether it's planning a campus-scale geothermal retrofit, reverse engineering policy stability across Europe, or debugging UTF-8 Excel glitches, he's always in the weeds, but this is by choice. Interestingly, he also has a degree in geology and theater. Malcolm, thank you for being here on the show today. So before we get into the main topics of our discussion today, why don't you take an opportunity to introduce yourself and then share how you got involved in the geothermal space?
Sure, happy to. And Elizabeth, thank you very much for the invitation. I enjoy watching these podcasts, and I've always wanted to be on. So when you offered me the opportunity, I jumped. So yes, a little bit more about me. I came from the oil and gas space. I'd actually had multiple different careers. I was doing GIS before I joined Shell. I spent 15 years or more at Shell. We'll talk a little bit more about that, but basically the first half of that was in upstream exploration, big scale, plate tectonics, paleoclimate, paleogeography, global scale, big picture stuff. And then I wanted to get out of that oil and gas space and into the new energy space. That's when New Energies was just getting started at Shell, 10 to 15 years ago. And so I joined a team there called Game Changer, which we will dive into a little bit. Spent 5 years doing that, spent another few years in the New Energies team doing more of that New Energies research. And then I found that I was not getting enough traction for what I was trying to do in geothermal within Shell. And then that's when I went outside, was consulting, helping, teaching, doing lots of different things until I joined Eavor less than 6 months ago. So what I'd like to do, if I can, is share some imagery, some inspiration for why I do the things I do and why I have such a broad reach. I actually have two quick stories because they resonate differently with different people. The first is the butterfly effect. I don't know if you've heard of the butterfly effect, but it's a part of chaos theory that says that there are cases where the beating of a butterfly's wings in Mexico can change the weather in, and then pick your favorite place, London, Moscow, whatever it is. And the idea there is that sometimes systems are very, very, very complex, and very small changes in the system can have dramatic effects. And there's a whole story behind how this came about. I encourage you to look up butterfly theory in Wikipedia. But what I like to say about it is that each of us are a butterfly, and each of us, if we beat our wings together, can change the world through small changes. So when I'm speaking to students, I say, I want you to be a butterfly with me, because the more of us that beat our wings, the better it is. The other imagery, and this only resonates to a certain group, and it is the Back to the Future. You may recall the series of movies called Back to the Future about time travel. The whole trope of that movie is don't make changes in the past, small changes in the past, because they'll have dramatic changes in the future, right? That guy gets a book, a gambling book, and he makes himself a millionaire, that whole thing. And to me, it's like, how do we not know, if we think that's true, how do we not also think it's true that if we make small changes now, that it won't have a dramatic effect in the future? It's the same principle. So everyone should try to make whatever impact they can, big, small, whatever it is, because they never know which one is the one that's the sports betting book that will change the world. So that's why I focus on the things I do. I like to inspire people to do what they can do with either the butterfly imagery or the Back to the Future. The problem with Back to the Future is this current generation, I tried it with my students this year, and they're like, back to the what? They had never seen the movie. So the whole metaphor broke down. So I had to think of another one, and I came up with the butterfly effect. So
I love that.
That's my inspiration. I got into geothermal through Game Changer. I was on the oil and gas side of this Game Changer team, and I wanted to get into the new energy side, and the only thing that fit my skill set of geology and all that was geothermal.
Wonderful. Okay, so when I look and I follow you on social media, and so I see often you refer to yourself as a black swan detector, which I love. Can you explain a little bit more about that?
Sure. So I should probably explain the black swan element of that first. It's an economic theory, excuse me, that comes from a professor at MIT who put forward this idea that, again, it's kind of related to this other stuff I've been talking about. A black swan. The story goes that for a long time, Europeans thought swans were white. Everywhere, all over England, all over Europe, white swans everywhere, until they got to Australia, where all the swans in Australia are black. And it's like, oh my God, those are black. Oh my God, So a black swan is something that you think is one way that is actually another. When you change it, when you recognize it, it has dramatic effect. And once it happens, people say, oh, well, that was always going to happen. And the example I cite, current example, is COVID, right? People thought, that it was never going to happen. Then once it happened, it had huge effects, still having effects. And the people began to say, oh, that was always going to happen. We knew there were viruses out there, and eventually one would break loose, et cetera, et cetera. So it's this sort of hindsight is perfect of even things that before they happened, people said they weren't going to happen. So my job at Shell, my last job at Shell, was titled Black Swan Detector. And Shell allowed me to have that title. And my job was to look for black swan ideas for companies that have these revolutionary ideas and in the new energy space. And so the idea was to nurture those things to the advantage of Shell. So that's the origin of the black swan, but there's imagery there that I like. One is the idea, if you see, swans or ducks swimming across a pond, they move slowly and majestically, but under the water where you can't see it, their legs are doing this, right? So that's a little bit of what it's like being a black swan. There's a lot of work going on under the subsurface to have this sort of majestic view. The other thing is I like the acronym BS detector, because that's a lot of what the job really is detecting the BS and filtering that out to find the diamonds in the rough. And in the Game Changer team, just to give you some statistics, we looked at hundreds of ideas, and I'll talk about a couple of them maybe if you'd like. But our success ratio and success really was getting an idea from a company to a point where it was investable. Not even it was in the marketplace. We just needed to get it to investable. Our success rate was less than 4%. How many groups at an oil and gas company have a failure rate of greater than 96% and still are still successful? Game Changer's been around over 25 years. The reason is any one of those successes, it's a black swan. It will be huge. And if you look at many of Shell's biggest successes came from an idea in Game Changer. And that's what led me to this philosophy around, you can have a lot of failure, but if you find a diamond or two, they can change the world.
So what were some of Shell's successes of technologies that they found?
The one they always cite is Prelude, the offshore oil and a gas refinery system that they put on board a ship so that they could take gas from the Exmouth Plateau and liquefy it and ship it to Asia without it ever touching dry land. And that idea came from the back of a cocktail napkin and was brought to Game Changer, and it reached a point where Shell spent billions to build this ship. So that's one particular example. Another example I'll give you is Greenfire Energy, and their first experiment out at COSO was co-funded by Shell Game Changer, and the money was spent on Vallourec insulated tubing for their closed loop. And look at Greenfire now. They're going great guns. So and it was one of the Greenfire team who came to me randomly, sent me an email and said, "Hey, we've got this closed loop idea. What do you think?" And that was where it all started. So it goes all the way from multi-billion-dollar platforms to several, I don't want to quote numbers, but co-funding experiments that lead to the growth of a company like Greenfire.
Wow, I had no idea. I didn't realize that their one of their, I guess, starts was with the Shell Game Changer. That's very interesting.
It was.
So was
Yes.
that your first introduction to closed loop geothermal?
My introduction to geothermal, so I talked to my boss during a year-end review, something like that, and I said, "Look, I'm in the oil and gas side. I'm tired of looking at new drill bits and all that. I'd like to get into new energies. I want to do geothermal." And she said, "Okay, I'll let you do that, but what I want you to start doing is go interview people within Shell, experts within Shell and outside of Shell, and give me a list of the reasons why not geothermal. Why are we not doing geothermal?" And so I came up with a David Letterman top 10 list of the reasons why not. And then my boss said, "Okay, now use Game Changer to address those reasons why not, because that's what we're good at." And so I made this list after careful interviews, and I was looking for those parts of geothermal that address these top 10 concerns. And in the end, the answer was, in my mind, closed loop geothermal. And that's how I ended up with Greenfire, and that's how I ended up with Eavor a little later on. Was that I was asking the questions, what was holding us back? And I felt that a lot of the challenges of an open loop style hydrothermal and EGS style system was going to be self-limiting, and the closed loop had an unlimited potential.
Interesting. Okay, can you share at least two of those top 10s of why not geothermal that you put on your list?
Yeah, sure. Number one on the list, and it was one of the ones, if you can't solve this, you might as well not solve any of the rest. And it was, in fact, the one that closed loop doesn't solve. The other 9, it does, but it is cost of drilling and casing. And that was obvious. Everyone said that one. Everyone knows that one. But I will say, for example, Eavor's design, which is to do an open hole completion in the multilaterals, a lot of that is focused on reducing the cost of drilling and casing. And so that was number one. And in fact, Eavor's design with all those multilaterals doesn't reduce drilling cost, it increases drilling cost. But we attacked the drilling cost thing by investing Greenfire Game Changer invested in several deep dives into drilling technologies. So we were going to solve that anyways, because we were going to solve it for oil and gas, and then use lasers, microwaves, all those things that are out there to solve that problem. So another one that I worry about that was on the list is the environmental impacts of geothermal, including induced seismicity, but also the idea that you bring, pollutants, heavy metals, radioactive materials, etc., from the subsurface that are stored down there safely, and you bring it up in the brine and you cool it, and it precipitates, and now you've created a mess at the surface. With closed loop, that doesn't happen. Now, sometimes that brine has lithium or gold or other valuable things in it, but in my mind, balancing this, the costs were higher than the value. And if you want to target lithium like they do in Salton Sea, which, by the way, we considered also while I was in Game Changer, then do that. But overall, if you're going to try to think about doing geothermal in an urban setting or semi-urban setting, having a lot of pollutants come to the surface and then having to deal with that mess is just as bad as slag heaps at coal plants and mercury and all that stuff we deal with that we're trying not to deal with anymore with coal. So I just felt like it was that sort of problem that you were creating for yourself.
Yeah. Okay, I understand this component. So let's turn now to talk about your 1 foot in academia. So you are a professor at the University of Texas and at Rice University. What do you teach? What do you talk about?
Yeah, so I teach a geothermal 101 class. It's a full semester class. I've been doing it for 4 or more years now. I usually teach one semester at UT and then a different semester at Rice. However, this fall, I will actually be teaching them back to back together in the fall. And I cover the spectrum of geothermal. It's a 101 course. It's really meant to draw people in and give them enough of an interest and basis to move forward in that idea. And that's the most gratifying part of teaching for me. I've taught GIS at Rice for, I don't know, 10 or 12 years or more. And every time one of them gets a job and makes a career choice in GIS, and I see it on LinkedIn, I get excited. And that's why I do the teaching I do, is I like to open minds to opportunities. So what I've seen happen now is that this current generation of students have been raised in a much more environmentally conscious ethos, environment, right? And they want to choose geology, but they think choosing geology means a career in extractive industries, oil and gas or mining. And what I try to open their eyes to is how you can be part of the green decarbonization revolution and be a geologist at the same time. And we talk about certainly focus on geothermal, but just as much as exploring for hydrogen or CCUS. Those are all subsurface geology heavy skill sets that you can do and pursue your passion for geology without having the negative impact. So I have many times now talked to students before or after a presentation, and they'll say to me, "Oh, you've opened my eyes. I didn't realize, and I'm stuck on the oil and gas track, but if I don't get a job, I'm turning to geothermal."
Yeah. So I'm curious. About the course. Is this designed for geologists, or are there engineers in your course? Are there folks who maybe are studying energy policy? Like, who takes this?
Absolutely. Yeah. So last semester at UT, I had 25 students. And they came from across the spectrum, from hardcore geology folks to petroleum engineers, several petroleum engineers. I had policy people from the LBJ school. I had environmental sciences people. I open the door to everyone because honestly, I don't do a deep dive. I do a broad dive.
Yeah.
And the amount of math and the amount of hardcore, formulas for a feldspar, blah, 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 we just don't do that. I don't want to turn these people off by getting too deeply in the weeds too soon. So we start with a fundamental understanding of geothermal, and then they do a project for a final project that involves finding some place in the world where they want to study the geothermal, and they go soup to nuts exploration. They use geofires to do a techno-economic study, and then in the end, the final presentation is a pitch to me, and I usually try to invite a guest judge or two. They pitch their idea for, here's a great place to go do direct heat. Here's a great place to do electricity, and it's anywhere in the world. And they really enjoy that because a lot of them come from other places. So my student from Nigeria looked at Nigeria or potential geothermal. That sort of allowing them to explore their own space, I think, is really important.
I like that. Yeah, if you ever need a judge, I'll be there. That sounds pretty neat.
Okay. Yeah.
Yeah.
In the
Okay.
fall, I'm going to have 2
Yeah.
classes and I'm going to need judges. You bet.
Yeah. Okay, keep me in mind.
Yeah.
All right. So you're a professor, but then you also are working at Eavor. So can you talk about what you're doing with Eavor? Maybe touch on some of Eavor's projects, the status, those.
Sure. So my title is strategic marketing director, and the idea is that Eavor is a software, not a software license, is a licensing based business model. Okay. Our hope in the long run is not to be drilling, not to be managing, not to be owning. We simply want other people to license our IP to go do these things for themselves. Now, what we found is as we first do our first projects, we've got to do it all because no one necessarily believes, and we got to show people that it's possible, and then they'll jump in. So in the long run, we're going to have a bunch of partners out there who are the drillers, who are doing the exploration, who are operational, who are owners. And so part of my job is to be out there looking for the partners. Once we prove the technology and we start, growing exponentially, we can't grow ever exponentially. To do all that stuff, we need partners to jump in. And so my job is to find the very big, the Schlumbergers, the Halliburtons, to help us, the Vallourecs and on down the spectrum to the 3-person shop in Warsaw, Poland, who know the geology and know the people of that particular area and will help us jump in to that country or that country. And my job is to find them and then qualify them as Eavor partners. So that's the strategic marketing piece of it. It's also about choosing the priorities of where are we going to go next? What country entries do we want to make in what order and why? Those kinds of questions. So I am not anywhere near the day-to-day operational. Lots of other folks at Eavor are doing that, but my job is, where will we be 2, 5, 10 years from now? You ask about projects. I can tell you our flagship project right now, and all the chips are on the table at Gerets Ried, south of Munich in Germany. Where we went to an existing geothermal site that had failed. There were a couple of wells drilled that didn't encounter the Goldilocks, of the right kind of flow rates and temperatures and volumes of brine and all of that. They were abandoned, but they still had the permits and they still had everything set up to go. So we said, okay, we're going to go. We now know the stratigraphy. We know the details of the rocks we're going to encounter. Let's go and do a closed loop there. So that's what we're doing. We're actually drilling what we would call 4 loops. So a loop to us is 2 verticals that go into a dozen or so multilaterals. And so what basically you can think of our normal plan is essentially to have two rigs drilling side by side, go down, go out, and then link up at the toes. Okay, that's the sort of design. But you can think of doing that into a formation, going towards the east, and then you go down in two more holes and go towards the north, and then the west, and then the south. So any one site could have 48 laterals going out in different directions, like the roots of a tree. And so that's the plan at Garrett's Reed. So we're just about to finish the first loop. And then we're moving the rigs 10 meters or whatever and drilling vertically again and going in a different direction.
So are you going to complete all of the loops before you do a circulation test on the first loop?
Yeah, so that's one of the interesting things about closed loop, because it's closed and you're controlling all of the variables or most of the variables. We have already built the power plant at Garrett's Reed. We don't need to do flow tests and, how fast is the water going to move through the cracks that I created with EGS. We know how fast it's going to move. It's a pipe, it's this big, and we know the flow rates. We know all of that. So we actually built the plant, and pieces of it were built off-site in Italy and then brought into Germany, and the plant is ready. As soon as we finish the first loop, the last lateral of the first loop, the water will flow in the plant, and the plant will start making electricity. The rigs will move, 10 meters, and then when that's all done, we'll connect that flow into the power plant. So, yeah, go ahead.
I was going to say, so how long to finish the remaining loops? How long will it take to drill and be up and running?
Those predictions are hard to make with a first of a kind style of project. I will say the first loop was a very large learning curve for us. And that's fine. That's part of the first of a kind, and you've got to be patient. And actually, the more you learn on the first loop, the less you have to learn on loops 2, 3, and 4. So we feel like, yeah, this is actually kind of good that we've had these challenges. But the other piece of it is that this is actually going to be a combined heat and electricity plant. We'll make electricity first, but only because the heat network in that area is still being built. So eventually, some of the hot water will be diverted into the heat network, and so we're somewhat constrained by how fast they can build the heat network, and we'll have to stage our delivery as the demand grows. Yeah, we're not talking yet about the numbers, but as you can imagine, drilling essentially 12. We drove 24 essentially horizontals, and they connect. So we call them 12 laterals, but that's really 24 horizontal sections. That is all about rate of penetration for us and bit life. Because we're at 3-4 kilometers of depth, trips take 2 days. So if we can drill a lateral in one bit, with one bit, that's a huge savings for us. So we're willing to take a less penetration rate if we can increase bit life. And that's really one of the lessons learned at Garrett's Reed, is that it's all about trying to complete a lateral with one bit.
Okay. That's great.
Yeah.
Okay, so what about the US? Is Eavor doing any projects in the US?
We certainly have feasibility studies going on in various places. I think it's known we're working with the University of Colorado, for example. We had a project with Joint Base San Antonio. But the challenge is that the U.S. is focused on making electricity. And that's, I think, to our U.S.'s disadvantage. There is so much more to do with heating and cooling directly. And directly means you're using 70, 80, 90% of the heat. You're using it in whatever application you want. When you convert it to electricity, your efficiencies are 9, 10, 12, 15% at best. And that's only if you get really high temperatures. So I feel like there's a lot of opportunity low-hanging, direct use, direct heat, direct cooling kind of opportunity in the U.S. That is left untaken because the focus of the investors, the focus of the legislatures is on making electricity. And I think that's a mistake.
So, okay, so what you're saying though is that it's not that there's not opportunities for direct use in the US, it's just the fact that it's harder to get capital or investment
Yes.
For those projects.
And legislative support,
Okay.
And economic support from
Yeah.
state governments and federal governments. Absolutely. That's changing, but I think that's a challenge for the US. I think another worthwhile challenge to talk about, and I should mention that I think it's April 28th, there is a session at Texas A&M College Station talking about geothermal in general. I'm on a panel talking about the challenges for geothermal. So I encourage you to look this up and go to Texas A&M if you're interested. But the panel that we'll talk about is some of the challenges facing geothermal and the financing one, and in particular, the U.S. focus is, I think, one of the challenges that we will talk a lot about. I think another one is the pipeline of people. I think I'm part of that generation where a lot of us went into oil and gas. All my peers are retiring now. We have Zooms all the time, and I'm retired. I'm afraid that we're talking about this. We should be using oil and gas people and data to do geothermal. That might be difficult because many of the experienced people are retiring. And the other thing is that while the oil and gas industry may be willing to let some of their people go, and they're doing a lot of downsizing now and letting people go, at some point they're going to start resisting because their best people are leaving to go do geothermal. I think there's a limit to the number of oil and gas people we can get. So that's why, tying back to my teaching, I'm doing the teaching is it's about filling the pipeline. If we're going to grow exponentially, we've got to have the pipeline of young people as well as the experienced people, because you need both. And if you look at Eavor, for example, Eavor is a very young company. You look around, there's a lot of people out of University of Calgary, mostly, but I think that you need both, and that's going to be another one of our challenges is to grow exponentially. It'll be a people problem as much as a financing problem.
Yeah, I agree with you. I will be at that conference. I'm really looking forward to it. Now we're about out of time, so I'm just going to ask one last question. You're going to be talking at this conference about some of the challenges. Do you want to share or speak just quickly about some of the things that you'll actually speak about at the conference?
Well, I've talked about two of them. I think one of the other challenges for Texas in particular. So let's get specific. I'm working now on a project for decarbonizing heating and cooling at Rice University, stone's throw from my house. And because I'm on the faculty, I'm on a committee looking at this. And very quickly, we got to the geothermal as the answer. Because we're not putting a nuclear plant at Rice. I'm sure no one in the neighborhood wants that. Even if we land on geothermal, I can assure you my neighbors and I will object to fracking. So EGS is out. There is no river running through the campus that we can build a dam on. So if you're talking about large scale decarbonization, you end up at deep geothermal or shallow. Maybe a bunch of shallow boreholes is the solution. There's a group looking at that, but the team I'm looking at is doing deep geothermal, and it's got to be closed loop. So we landed on Eavor, fortunately. But the challenge we face is in Texas, and I was part of the group that TexGEA decided to put forward legislation 2 years ago that the surface right owner owns the heat. And so if we try to do a project under Rice, we can't go north and south because there are neighborhoods and there are thousands of people with little tiny lots, And every one of them has to give permission and then wants a check. And that will become unmanageable.
Yeah.
So for our design, we're actually going east-west. So if we go to the east, it's City of Houston owns Herman Park. And so we can go under Herman Park if we get permission from the city, pay the city royalty. That's fine. If you go to the west, you have the Rice Village. Well, it turns out Rice owns the land. So underneath the Rice Village. So one of the challenges we will face in Texas doing urban, suburban, campus scale, whether it's a business park or a campus or Texas Medical Center. What a great place it would be to go do heating and cooling at Texas Medical Center. But going anywhere in any direction with the Texas Medical Center is going to be a challenge. So I think we're going to have to modify the legislation in Texas to accommodate for doing geothermal in urban and suburban settings, because the land ownership thing is going to be difficult. My proposal is that in an incorporated area, in other words, a city, the city owns the heat. And then the revenue that's raised goes towards reducing property tax. And that way, the whole city benefits from the heat underneath that city. And I feel like that's a reasonable compromise. But yeah, so that will be a challenge. One of the policy kinds of challenges is the fact that in many places, we don't have rules about who owns the heat.
Sure.
If you try to do it in West Virginia, in Pennsylvania, New York, Louisiana, there's no rules. Texas decided to make rules 2 years ago for the first time. But in places like Nevada, Utah, et cetera, that's all been cleared up. But yeah, one of the challenges is going to be a policy challenge related to making the right set of rules for the wide variety of geothermal opportunities that are out there. You need to have rules that are good for everyone. And I don't think we've landed quite there yet.
I didn't realize that. That is very interesting. Really exciting to see that Rice is looking at deep geothermal in particular. Lots of good stuff that we've discussed today. I want to thank you for the conversation. And I also want to thank all of our listeners for joining us on this episode of Geothermal Unleashed.
Thank you.
Yes, and I hope today's discussion has sparked new insights and deepened everyone's understanding of the geothermal industry's incredible potential. Until next time,
let's beat our butterflies' wings together.
Yes, I love that so much. So until next time, let's keep pushing the boundaries of what's possible, and let's continue working together to unleash the full potential of geothermal. Thank you so much, Malcolm.
My pleasure. Thank you.